Good morning, Quentin.
Good morning, everyone.
I see you're in a nice hotel room for today.
As nice as hotel rooms get, yes. They get a bit tiring after a while.
Yeah. We usually get started at about 8:03, 8:02 or so. So let's give it another minute for a few more folks to join.
I put a link to the document framework that I put together. It's a very rough idea, and it's definitely open to alternative suggestions. I think we're all going to try and put something together for today and pick the best one.
Yep. On the agenda for the day, we've got two things lined up. We've got one Xing from Huawei to present on OpenSTS for about 20 minutes, 25 minutes, and then about 5 minutes questions. And then the last half was going to be the wireframe discussion. Does that sound right for everybody?
Sounds good to me.
Okay. All right, well, let's kick it off. So welcome everybody to another SWG call, hot off the heels of KubeCon in the EU. I want to thank everybody who was on the call for joining us in those sessions in Europe. I think that we had some great attendance at both of our intro session and our advanced session. I think at our advanced session, we actually spent about 35 minutes and went around the room talking about what cloud native storage is, and I thought it was a great session where we collected a lot of really good feedback from everybody. So thank everybody for participating and being there. And I definitely see a few new names on the phone today. So that's fantastic. Is there anybody out there who wants to introduce themselves if they haven't attended the working group before, and just let us know who you are and where you're from and what you're interested in?
I'm happy to introduce myself, Matt Jarvis from Mesosphere. My background's in storage development, although at Mesosphere I run the community and evangelism teams. So just interested in getting involved in this working group.
Excellent. Welcome, Matt. All right. Anybody else?
Hey, this is Ben Swartzlander from NetApp. I've been working on various storage management solutions for a long time, most recently OpenStack, and I'm getting into Kubernetes, and this is my first working group meeting.
All right, excellent. We've, in terms of the agenda today, we've got two things. We've got one, we're going to hear from Xing at OpenSTS, and then we're going to talk about the wireframes for the storage white paper. If anybody has any additional items that they wanted to talk about or questions, feel free to go to the agenda and throw them on there. And if we have time, then we'll get to them at the end. So with that, I'll hand it over to Xing to talk about OpenSTS.
Hi, so let me share my screen. Okay, can you see my screen?
Yep.
Right. Okay. So I'm Shinyoung. I'm the lead architect on OpenSTS, which is an open source project under Linux Foundation. I joined Huawei 6 months ago, working on this very interesting project. Before that, I worked for Dell EMC. I'm also a contributor in Kubernetes and CSI, currently working on the snapshot feature. So today I'll be talking about what is OpenSTS, how to use OpenSTS to provision and manage persistent volumes, how we map OpenSTS profile to Kubernetes storage class, and how we define our profiles for policy-driven storage provisioning data management. And I will talk about how to use OpenSTS to provide data protection and disaster recovery for persistent volumes using Arraybased and Hostbased replication. And I'll talk about the roadmap for our Aruba and Bali release and who are involved in the OpenSTS community. If I have time, I will do a demo. OpenSTS has two core projects. The first one is Sushi, the northbound plugin project. It has plugins for the container orchestration systems, OpenStack, VMware, and other northbound ecosystems. And second project is called Hotpod, the storage controller project. It provides unified control for block, file, and object services that supports a variety of storage platforms. This is our project framework. So in addition to discovery, provision, orchestration of storage, we also have plans to provide extensions and tools for deployment, monitoring, and also include AI and machine learning. I will show you a roadmap later on so you can see what we have already implemented and what we are still working on. This is the OpenSTS architecture. On the top is the OpenSTS northbound plugin. And in the middle is the OpenSTS controller that has an API server that takes requests from the northbound plugins and send that request to the selector and other controllers. The selector is our scheduler that takes the request from the API and compares that with the capabilities reported by the backend and finding a matching backend. And the policy engine is a component that can execute some policies asynchronously. So for example, it can execute a snapshot policy to take snapshots periodically. Volume controller is the component that handles volume operations such as create and delete volume. And we also have a DR controller that understands the replication logic that will handle replication. It needs to communicate with the volume controller and other components. And the dock is the docking station that hosts volume drivers and replication drivers. So for the volume drivers, we have a driver for Cinder, Ceph, LVM, and other vendor driver. And for the replication driver, right now we have a work in progress DRBD driver for host-based replication. The communication between the controller and the dock is through gRPC. And we have a database, an etcd database. But we also have a plugin framework for the database so we can add support for other database in the future. This diagram shows the relationship between Kubernetes, CSI, and OpenSTS. So here we have a Kubernetes master that has controllers and API server running. And we have a Kubernetes node with kubelet and has two CSI plugin pod. One is the CSI controller plugin pod that has the CSI helper containers for provisioning and attaching, and an OpenSTS CSI plugin that is performing the controller functionalities such as create, delete volume, controller, publish, unpublish volume. And we have a CSI node plugin pod that has the CSI helper container for driver registrar and a OpenSTS CSI plugin for node functionalities such as node stage, unstage volume, node publish and unpublish volume. And OpenSTS CSI plugin communicates with OpenSTS controller, which will find a storage backend, and it manages to perform the volume provisioning operation. On the right-hand side, we have a OpenSTS northbound plugin. This one shows that in addition to CSI plugin, we also have a Flex volume plugin, a dynamic provisioner, and also integration with a service broker. This diagram shows how we map OpenSTS profile to Kubernetes storage class. So admin creates a profile in OpenSTS, then admin creates a storage class referencing the profile. created in OpenSTS. Then the user wants to create a PVC specifying the storage class name created by the admin. And that request get passed through the OpenSTS CSR plugin to the OpenSTS controller. So the OpenSTS controller has the profile and it knows how to find the storage backend that can perform the create volume request. OpenSTS profile is based on swordfish specification, and swordfish is based on redfish specification. Redfish is an industry standard that defines specifications to manage scalable platform hardware. So it provides definitions for chassis, which is the physical view of the system, and also a logical view of the general purpose systems. Swordfish is an extension of redfish. It provides the specifications to manage storage systems in a cloud environment. So it has definitions for storage systems, such as the model number, serial number, storage services for block, file, and object, and other informations about the storage system, like volumes, storage pools, file systems, and so on. So to define our profile, we can specify properties for provisioning, data protection, replication, migration, snapshot policy, and admin can also specify custom profile properties. So here, the selector component in OpenSTS will look at the profile passed in from API and compare that with the capabilities reported by the storage backend and finding a matching storage backend that can perform a request. If there are multiple storage backends that can perform a request, it will just choose the one, the first one in the list. So here is an example how we can define profile. Data storage line of service, this is a definition from the swordfish spec. It has 3 properties: recovery time objective, how soon we can access to the alternative replica if a failure occurs, the provisioning policy, whether it's a thin or thick, is space efficient. So if, let's say, DDoB is enabled, then that means it is efficient. The I/O connectivity line of service, that's another definition from the swordfish spec that includes access protocol, whether it's iSCSI, FC, RBD, or other protocols, the maximum IOPS, and the maximum bandwidth. For replication, we use the data protection line of service defined in swordfish spec. So that includes recovery geographic objective that defines a failure domain, whether it is at a rack level or availability zone or region level, and RTO and RPO. Replica type will be mirror for replication. And also the replication update mode specifies whether it is async or sync, whether consistency is enabled, replication period, and replication bandwidth. And then for snapshot, we can specify policies, how often we want to take snapshot, what time, daily or weekly, monthly, and a retention policy, whether we want to keep a specific number of snapshots or whether we want to keep a specific snapshot for a period of time. In this diagram on the left-hand side, it shows a profile named high performance that is matched up with a storage backend 1. And on the right-hand side, we have a profile named high capacity that is matched up with storage backend number 3. So here are some examples of a storage class YAML file. In the storage class YAML file, we specify the provisioner as CSI OpenSTS plugin. And on the parameters, we specify the profile as high performance. So this can be either the profile ID or the name. the PVC YAML file, we just specify the storage class name as OpenSTS CSI high performance SC. That's the storage class we created using the YAML file on the left-hand side. So to run OpenSTS CSI plugin, we can just use the deployment YAML files in our repo. And after that, you'll find 3 CSI pods running. The first one is a attacher plugin pod. The second one is a node plugin pod. And the third one is a provisioner plugin pod. So they work together to perform the CSI plugin functionalities. This diagram shows how we use a snapshot profile. So the controller gets a request to create a volume. And in that request, it will get a snapshot profile that is passed from the Kubernetes storage class. The controller will first create a volume, and then based on the snapshot profile, it can periodically call the driver to take snapshot based on the schedule specified in that profile. And then it can also periodically call the driver to delete a snapshot that is already taken based on the retention policy. And the controller can also ask the driver to upload the snapshot to a object store on-prem or somewhere in the cloud based on whatever is specified in the profile. Without OpenSTS, if the storage hosting the persistent volumes is damaged for some reason, in this case, the containers will lose access to the persistent volumes. So if we use OpenSTS to manage the storage, then we can set up remote replication. So if something happens to the local storage, we can flip it over to the remote side. So the container can still have access to the volumes. This shows the workflow for creating a replication pair in the case of array-based replication. So here, the controller, for simplicity, I didn't specify the DR controller and the volume controller, but the DR controller is the one that knows the replication logic. It can detect whether the storage backend can support array-based replication or not. If it does, it will go through the array-based replication workflow. Otherwise, it will go through the host-based replication workflow. So in this case, the first source volume and target volume will be created. Then the DR controller will ask the volume controller to create the replication relationship between storage 1 and storage 2. And after the replication relationship is established, we can do failover if needed. And for host-based replication, here we have a few more types of docs shown here. The first one is a regular doc hosting the volume driver. The second one is an attached doc that is responsible for attaching and detaching a volume. The third one is a DR doc that is hosting a host-based replication driver. So it's a DRBD driver in our case here. So the workflow will be a little different. So first you'll create a source volume and target volume, and then the DR controller will be asking the volume controller to attach the source volume on host 1 and attach the target volume on host 2. And then it will communicate with the DR doc, which asks the host-based replicating driver to create a replication relationship between host 1 and host 2. And also there will be some configuration files on host 1 and host 2 that need to be updated so that the replication relationship is kept in sync. So after that, this is a setup and ready. For host-based replication, for DRBD we support DRBD version 9.2 that supports automatic failover. So that means if a user unmounts the file system from the primary and mounts the file system on the secondary host, failover will happen automatically. There's no menu CLI command from the DRBD side after that. So here are the few items that we will be working on in the future. The first one is the thin OpenSTS in an containerized environment. For some applications, they may not need a full-blown replication. They may not need a full-blown orchestration engine that supports multiple backends. So in this case, we will provide a lighter version of OpenSTS. So basically, the CSI plugin will be communicating with the OpenSTS API, which will communicate with the doc directly. The doc will be hosting a specific storage backend driver. And the database is optional in this case. We will also be working on data migration, both host-based and array-based replication, host-based and array-based migration. And for multi-cloud control, that is migration across different clouds. It can be private cloud on-prem, or it can be public cloud like AWS, Azure, Google Cloud. And we also have planned to work on multiple OpenSTS deployment support. Here's our roadmap. So at the end of last year, we have a ZLAN release, that's a beta release. We have some basic volume operations. We support standalone sender. We have a native driver for SAP and LVM. We have a CSI plugin and also a flex volume plugin and a dynamic provisioner. And for Aruba, the first half, so we're planning to release that at the end of June. For the Aruba release, we will support a simple OpenStack integration, which means OpenSTS can work seamlessly within the OpenStack environment. And we also have replication support for host-based and array-based that I talked about earlier. And we have a UI, and we have storage profiles and virtual pools. The NVMUF support that is being worked on by Intel. Right now, it's still in the design phase. Enumeration is referring to querying resources based on a filter. And we also have a few drivers for SAP, LVM, and IBM, and Huawei driver. For the second half, we'll have a body release. We'll be focusing on the multi-cloud control. We will be working on data migration, monitoring. That will be some volume metrics and some capacity usage monitoring. And multiple OpenStack will support S3. And the UF, we should have a driver at that time. Also group snapshots and group replication. Right now, our CSI plugin, we only tested that with Kubernetes. So we want to test that with Mesos and Docker as well. And we also hoping to have a swordfish southbound driver from Dell EMC and NetApp. And for Cabri, that's the T190 in the first half, we'll be focusing on storage intelligence. We have a technical steering committee. We have members from Huawei, IBM, Western Digital, Intel, and Lenovo. And for our end user advisory committee, we have Vodafone, Yahoo Japan, NTT, and Toyota. So our end users are participating in our design as well. So here shows the organizations that are supporting OpenSTS. And Limbit is our newest member. They're working on the DRBD replication driver. So here we have the OpenSTS repo under GitHub that has our projects for the northbound plugin and the southbound controller and a few other repos. We have a Slack channel, and we'll have a few mailing lists. You can subscribe if you want to get information. And we also have weekly meetings. So to accommodate different time zone, we run these meetings bi-weekly. One meeting time is on Tuesday at 9 a.m. Pacific time, and then there is another meeting time which is on Thursday at 6 p.m. Pacific time. So those both meetings are bi-weekly, so you can check out. So Clinton, how am I doing on time?
You got a few minutes left, so if you wanted to do something pretty quick, or we can open it up to questions, whatever you'd like to do.
This is so this is a 4 minute. Do we have 4 minutes for the demo? So this is a recorded demo.
Is it, Quinn, is that all right?
Recorded demo.
Demo?
It's a recorded demo. It's a little bit over 4 minutes.
It sounds fine to me. I guess it depends how many of these wireframe docs we have that we want to get through.
Oh, okay. So maybe we can go ahead with questions then. It's fine. So this demo basically just shows our UI.
Yeah, if you have a YouTube link to it or something like that, then we can put that in the chat and then.
Okay, sure. I can post that. Yeah, sure. So I can open up for questions then.
Yep. First question from Louise is OpenSTS asking to be a sandbox CNCF project?
No, we are already a project on the Linux Foundation, so we don't have plan to asking that to be under CNCF. So it's already a Linux Foundation project.
Okay.
Hey, Zinga, this is Bassam. I have a question. In what circumstances?
I'm sorry? Yeah.
If I was a Kubernetes developer, in which situation would I use OpenSTS versus, say, just CSI?
Yes, you're talking. Well, so we do have a CSI plugin, so you can use the CSI plugin, and then you can leverage, all the features that we support. So I mentioned that we will be working on a lighter version of OpenSTS as well. So with that, you can actually have a more, let's say, a more basic CSI plugin, right? You just have the CSI features, but then you, with a southbound OpenSTS driver, you can actually use that driver both in the thin OpenSTS and the full OpenSTS. And then if you want to leverage all the features that we have, then you can use that in the the full OpenSTS environment. Does that answer your question?
Yeah, I guess I'm trying to understand from an end user perspective, why would I use OpenSTS versus just use Kubernetes dynamic volume provisioning and CSI?
Oh, okay. Yeah. So if you you can definitely, of course, just use a. You're talking about a CSI plugin that is does not that directly goes to your backend. Is that what you're talking about, right? I think that's what you're talking about. That's how that is different from a CSI plugin for OpenSTS, correct? Right? Because
no, actually, I'm saying what from if an end user wants to use that is using Kubernetes and is already using dynamic volume provisioning in Kubernetes.
Yeah.
Why would they switch to using OpenSTS?
Okay, yeah, so OpenSTS has other focus as well. As I said, in the second half of the year, we'll be focusing on data mobility, the multi-cloud control. So that will allow you to migrate data from across cloud, right? So OpenSTS basically provides additional functionalities that because CSI plugin itself right now, at least, right, it's still evolving. It only has, create volume, delete volume, attach and detach, right? And then the snapshot is coming, but still pretty basic, right? So with OpenSTS, you can have more functionalities in addition to that.
Okay, thank you.
Yeah, thank you.
All right, one more question.
So a follow-up, Shing. So these functionalities are exposed to users through OpenSTS, or is it just exposed to the admins? Let's say if somebody wants to back up and restore their volumes, can users directly do it themselves, or this is something an admin-only operation?
Oh, those are user operations. So the admin basically sets up the profiles and the sort class and all that.
So in the case of backup and restore, if you do replication to a remote storage backend, how seamless is that operation? For example, if you fail over from backend 1 to backend 2, does it involve updating the PVs or creating new PVs? How's that exposed to the users?
Yeah, that's actually a very, very, very good question. So right now, our replication implementation, it's still at the first revision. We're still wrapping up with the host-based replication, right? So we actually need to provide some steps on how that is done so that user has a better experience. But I think by the time we release at the end of June, we should have some better description on that so that I can share with you.
Okay, thank you.
Yeah, I had a related question, maybe a little less direct, but to what extent does the typically, I guess it's a container that is attached to this OpenSTS storage. How smart does the container itself need to be to deal with a lot of these features? So, for example, does the container see when snapshots are being taken, and what consistency model does it see? What happens when failure? Does the container have to unmount and remount volumes, etc., when failover is happening? These kinds of things, or they're all transparent to the container.
Yeah, I think for those things that we definitely need to sort out some of those details, because as I said, the replication feature, we're just wrapping up. We're still waiting for the host-based replication to be done. I think I will be provide more details on how to do that in the future. Yeah, so right now, basically, we are just basically some of how the container can figure out whether it is changed or not, right? So we want to provide a smooth transition. So basically that means that when we create the volume, we need to provide some information in that the CSI has a volume source that needs to have information about the replication piece as well, not just the volume of the primary site, right? So those are the kind of details that we are still need some fine tune, and I should have some more details later on.
Okay, excellent. Just in the essence of time, I think we got to move on to the next agenda item. Shing, thank you so much for preparing and doing the presentation for us today. If there's anybody that has any follow-up questions, feel free to send them to the email group or directly to Shing.
Thank you.
Yeah, really, really great presentation, Shing. Thank you for the trouble you put into that.
Thanks.
Okay, to you, Quentin. Or not.
Well, yeah, I don't necessarily need to lead the discussion, but okay. I think we agreed 2 weeks ago that we would, whoever was interested in proposing an outline for this document would arrive today with that in hand. So I guess first question is, has anyone prepared such an outline? I assume then the answer is no.
I think on the one that I had was the existing one, so I reviewed that as well a little bit over the break, so I was going to talk about that in comparison.
Okay, that makes sense. Should we go through this new one first? I think most people have seen the previous one before, so maybe we can start with the new one and then see what differences we've got to make. Does that make sense?
Yep, that's fair.
maybe I can present. Give me 1 second. How do I do that now? There we go. Can everyone see the document?
Yep.
Okay, so this is not really rocket science. Basically, what I tried to do was, first of all, just make very clear what our goals and non-goals are. I hope those have been reasonably well communicated so far, but perhaps I'll just whip through them again to make sure that everyone is on the same page. So the main aim is to clarify the terminology across, everything that can reasonably be called storage. So we're not going to limit ourselves this time around to block stores, but rather, anything that people are using and commonly understand to be storage. So block stores, key value stores, databases, file systems, volumes, object stores, etc. We're going to provide some information about, in very general terms, how these things are actually currently being used in production. And the emphasis there being on actually being used in production. So if we wish some of these things were being used in production, that doesn't count. And then I guess perhaps most importantly, once we've clarified all the terminology and how these pieces fit together, we're going to try and characterize the various different types of storage and specifically with respect to their primary properties. And this is not a product competition shootout. This is some of these types of storage are fundamentally different than others in terms of availability, scalability, consistency, durability, performance, and API. So basically, we want to just get everyone on the same page, understanding what those properties look like across the different types of storage. As importantly, the non-goals, we're not going to try and define what is and is not cloud native storage. I think until we have the goals sorted out, that is an exercise fraught with peril. And we're also not going to provide any recommendations to the CNCF as to preferred storage approaches or solutions. We just want to get on paper, what the different properties of the different kinds of storage are. Once we've finished that, then we probably will undertake a phase 2 where we might tackle some of the more ambitious goals, like defining what we think works well and not less well in cloud native, and perhaps providing some recommendations. Any questions or comments so far? So the outline, and in fact, you can see most of this from the actual table of contents that I put together. But basically, we take each, in fact, maybe I will go back there. We take each of the fundamental types of storage, and I've put a few proposals here, and I'm sure there are some missing bits that people might want to fill in, but I provisionally recommended that we look at block stores, file systems, object stores, key value stores, databases, and that's about it. And then for each one of them, we look at what are the data access interfaces, so how do you get to these things, management interfaces, how do you manage them, and then for each one, what the primary classes are. So for block stores, we clearly have local block stores, remote block stores, distributed block stores, and perhaps there are some other types. And define, what we mean by each of those words and how they kind of fit together, if at all. And basically the same pattern. The comparison, I proposed a table that looks roughly like that for each type of storage. So what are the relative properties with respect to availability, scalability, consistency, durability, performance? And I think we can, make some broad statements there about, for example, a local block store is not available when a single node fails. Whereas a remote block store may have availability that is independent of the node accessing it. Yeah, some similar arguments for durability. What is the likelihood of your data getting lost? It's clearly higher if you have a local block store than a remote block store. a single-hosted remote block store is again less durable than a distributed block store with replication, etc., etc. And then I just, the same pattern for all of the other areas that I mentioned. I also added a section at the end. I think there are a bunch of types of technology that kind of rear their head across many of these different areas of storage. Things like consensus algorithms, Paxos, Raft, two-phase commits, distributed transaction algorithms, just actually understanding what consistency, coherence, and isolation mean. This word consistency, for example, gets used in many different contexts and can mean completely different things. The canonical example being that the C for consistency in the CAP theorem is not the same as the C for consistency in the ACID acronym. So we should, all be talking about the same consistency when we're having these discussions. So that's me. Yeah.
What's the context here from a cloud native perspective?
Well, I think that that before we can even, so we have some vague notions about what cloud native means, scalable, available, etc. But I don't think we necessarily have a clear understanding, I certainly don't, and maybe this is a common problem, of what those properties look like for all of the existing kinds of storage that we know about. And I think that once we have these properties well understood and the terminology well understood, I think we can then pick a subset of the range of, for example, availability or scalability or consistency and say, if it falls below a certain value here, then we don't think that's should be considered cloud native, or some explanation of why we still consider this part of the cloud native landscape, because it is perhaps used as a building block for something else that increase the availability. So that's the thinking behind it.
Hi, Quentin. It's Alex here, and I just want to apologize. I knew I was supposed to be putting a white paper together, but just didn't have the time, unfortunately. But so this looks actually pretty good, but I think there's a huge amount of focus on defining the storage systems, and I think we could probably add a couple of things that are probably a bit more generic as well to this. So what I'm thinking is, in all of these, with all of these different storage systems, whether it's block or file or object, etc., we probably have a whole bunch of things around interfaces and how we compose stuff. So I think it's worth talking about the interfaces like, DVDI and the Kubernetes drivers and CSI and those sorts of things, and how that helps developers compose their storage requirements into the environment. And I think we probably also need another section to cover API frameworks and orchestrators and operators and things like that, perhaps, to cover things like, the X-rays and the OpenSTSs and the Rooks, because they're not storage systems in that they're not, a block store, for example, but they are a crucial part in how the storage system links into, say, an orchestrator in a cloud-native environment. What do you think?
Yeah, I absolutely agree. And just to be clear, I knocked this together at like 9 o'clock last night in 20 minutes or something. So, and I also tried not to make it so big as to be undigestible. But yes, so implicit in here, and we can decide how we want to structure it. There are two things that are not sort of explicitly called out in the headings. One is, how do these things fit together? So I think it's worth talking about the fact that, file systems are built on block stores. Some distributed file systems are actually built on distributed block stores, others are not, and those kinds of discussions. And then, you know, there's the management interfaces, which I mentioned in each section, but there's also the, you know, how these things fit together and what the orchestration story, if any, around them is. And I don't know if we, you know, have that as a separate section once we've described all of these, you know, fundamental types, or whether we weave them in to the discussion about each type. So, you know, what orchestration systems do we know about that orchestrate block stores? And are they different than ones that orchestrate key value stores or databases, for example?
Yeah, I agree with you, Alex, too. I mean, I think that the title of it could be misleading on itself, you know, where you're calling it a CNCF storage landscape. But this like, if you look at the projects that are considered cloud native, you know, the ones that you mentioned, right, there wouldn't really be a place to describe them on here directly within the index at the moment. And so whether like it's the scope of it that's just very clearly like elementary, kind of defining the, you know, the data plane aspects of like what these different stores are and why you'd use them, or whether the scope is a little bit beyond that to step up into, you know, how these things are orchestrated or interfaced with. I think as long as that's clear, that we should be fine. But as is, it seems like storage landscape is probably a little bit too broad of a term for the white paper, considering what's in the index.
Yeah, I think it's probably the index that is inadequate rather than the title that is too broad. So,
yeah.
So clearly orchestration belongs in here somewhere, and I don't have a strong opinion about whether it is a section after databases here, which is like orchestration of storage systems, or whether we weave it in. Does anyone have any opinions on that matter?
I think we should definitely have a section on interfaces to cover, you know, things like the CSI project and different driver interfaces and that sort of thing, and that then would tie into orchestrators and operators, you know, so things that help with those interfaces, like Rook and OpenSTS and Rexray and those sort of things. And it probably would help, I think, then if there was also maybe a primer as to kind of specify the different types of deployments where you can find these services, because I think that's generic to a lot of these things. So the sort of questions I get asked repeatedly when we're on the standard conferences or when I'm at meetups and things is, you know, what are the differences, say, between block services offered by, say, cloud providers versus block services offered by software solutions versus block services offered by say, hardware providers, and I'm picking block services just as an example, but obviously that applies to file systems and object stores and everything else too. And I think it probably would be worth looking at that, because you kind of have three levels as to when you're trying to decide what's the best solution for your particular use case, which is one, how are you going to automate and compose this and make it, you know, fit into your CI/CD kind of processes. And then secondly, which classes of services are you going to be consuming? Are you tied into something that you've already got on premise, or are you looking at for cloud instances, or are you looking for software solutions? And then thirdly, once you've decided that, you've kind of got different types of storage systems like block and file and object and key value stores, which then give you different capabilities in terms of, you know, the comparisons that you've described around availability and durability and performance and those sort of things.
This is Louise from Portworx. Thank you for putting this paper together, first of all. One of the things I wanted to ask is what do we expect from the reader when they read this? Do we expect that they don't know anything about storage, or do we expect that they have some idea about storage? And if we don't expect them to be very knowledgeable of storage, because storage is quite complicated, maybe this is it sounds to me like this is a reference, right? This is a reference of terms and technologies. And then maybe another paper that describes more higher level stuff reference this paper. So this will be more like a location for definitions of terms and technologies. And then we use this as a foundation for other documents. I just think that we shouldn't just make this document so big that it becomes unbearable. We just make it simple so that it's just a reference for people to look at their section, read what they want, and then go back to another document that they were describing more of a, information on how to use interfaces and things like that. Just my opinion.
It's an interesting comment, Ardalan, and part of me thinks that what's in this document, like in terms of defining the different types of data storage, like it's been done already somewhere. And if this doesn't have a cloud context to it, like how much of this are we just repeating and putting in one place specific for CNCF? And I don't know the answer to that. Like maybe someone hasn't done a great job at comparing and contrasting the different data stores that are out there.
Yeah, I mean that's a good point. I mean everything that we're saying here is been done for the last 20-something years. So we maybe by writing it, we all agree that this is the definitions that we're using, and maybe that's a benefit, right?
Well, so I'm just going to throw in maybe a tiny curveball here. So I kind of agree that obviously all of this is being done, and there are lots of resources about these different things. But I think the one thing that I have noticed is in many organizations, storage was previously managed by some core team. And what's really different in cloud native environments is that the developers get exposed to storage, and often for the first time in a way that that they're learning about it.
Yeah, I agree.
So even though some of these things may be documented elsewhere, having a reference for people is really, really good, because you'd be surprised how many times I'm speaking to developers and they actually generally don't understand the difference between block stores and object stores and things like that. So I do think it is actually useful to have this as a starting point.
Yeah, I agree with that. Absolutely.
Yeah, as for the previous comment, I've sort of got pressure from both sides. One being, let's keep this thing simple and relatively uncontroversial and get something out the door quickly. And the other one is, well, if we're not defining exactly what we consider to be cloud native and what we don't, and covering all the cloud native orchestration techniques, then we haven't really got anywhere. So, and I'm sensitive to both sides of that argument. I think if we can knock this thing out pretty quickly and move on to, if we decide that we want to separate this document, which just defines the terms and basic stuff that we're talking about, and then have a separate follow-on document that talks about orchestration of all of these things and how they all tie together and different approaches to managing them, etc. I'm okay with that as long as we get to that one, soonish.
So is it fair to say, Quentin, that this should be a end user focused document then?
I think this is, ultimately for the use of the CNCF in general. For example, I don't think everyone on the TOC is necessarily a storage expert. So when they're being asked to vote on inclusion or exclusion of projects at some point in the future, they do need to understand the stuff in this document to be able to have an opinion and follow the debates. I think similarly, consumers of CNCF projects and technology, come to the CNCF to learn things. How do I do stuff in cloud native land, and what are the different approaches, etc. And they will also be consumers of this. Does that answer your question?
Yeah. So partly what I was trying to get to is that you could argue that there are two perspectives that we care about. One is as an end user, I'd actually include the TOC as part of that. How should they think about the landscape of storage, orchestration, etc. Right? Essentially from a consumption and understanding what's available.
Yeah.
There's also a storage provider or a developer perspective too, which comes up here. And conflating the two, I think, is very, it's probably not a good thing. And so I think this document is from an end user perspective.
Correct.
Okay. Great.
All right, so is anyone sufficiently uncomfortable with this outline that they would like to propose a different one? Or should we just use this as a starting point and massage it as we see fit?
I think this is fine. Again, I feel it is a reference from my point of view.
Okay. Don't be shy. I will not be hurt and crushed if you think my outline is terrible and you want to propose a different one and you just haven't had time to. That's totally fine. What I was going to suggest is that we decide whether we're going to use this. We can make that decision now, or we can give people another week or two to come up with alternative proposals. It doesn't sound from the group like we need to wait that extra 2 weeks or whatever. We can start with this. The next decision we need to take is, do we want to cover orchestration in this document, or do we want to defer it to a later document? And I'm reasonably comfortable with either approach. Thoughts?
I just like keeping things simple. I would do it for the next document. So you say, actually, we finished one. So, but if you want to keep an open task, then you can add it to this one.
I'd argue that from an end user perspective, they should not only know about the kinds of storage systems that are available, but also, things like orchestration and interfaces. I think Alex was making a similar point. So, as an end user in this cloud native space, I'd like to know about the options available for storage.
I was just saying that this looks to me like the storage landscape. Like this is like the storage definitions, and then we got a container orchestration landscape, which consumes this document. That's the way I'm thinking about it. I mean, it could be the part, chapter, or something, and we can even combine them both. I'm not saying not to. I'm just saying I'm trying to divide it into that model.
I think that makes sense, and I think we can keep both of those objectives happy So what I would suggest we do is we, rather than try and like interleave all of the orchestration stuff into the current layout, we add a section over here that specifically deals with, we can call it storage orchestration.
Yeah.
And the orchestration is kind of a fancy term. I mean, it's actually management.
I mean, I feel like it's something as simple as just adding a little bit of cloud context to this to say, hey, these platforms these are the different types of platforms, and here's the different characteristics. But when you're in a public cloud, they can be available to you. When you're in cloud native, you can actually do it yourself. And the definition or the description of what this is like and how it happens would be in the next white paper.
One of the primary goals that I would like to get out of this document would be to clarify the terminology and taxonomy, which I think was one of the goals that we wanted to get out of this document. And for me, it's really important that an end user can understand, from a terminology point of view, the difference between the interface and the orchestrator and the actual storage system. That is really, really important, because again, this is just based on questions that you get while at conferences, and you get people asking, they're unsure as to whether CSI is a storage system, for example, or whether CSI is a file system, and I think just explaining those sort of base terms somewhere at the beginning of the document would be incredibly useful to end users. Just if we're using this as a terminology taxonomy kind of guide, it's useful to get that out of the way first.
Yeah, that's reasonable. One way of doing it would be to perhaps start this off with a with a kind of a very basic diagram saying that, all storage systems have a data access interface, a management interface, and there are, just some of the sort of common components of all of these systems, and then use those terms through the rest of the document with specific, put CSI in where it belongs and explicitly say that it is a management interface for block stores, for example.
Yeah, makes sense.
That sounds fine to me. So I think we put the orchestration in this document, and I think we put it after the description of the different types of storage and their relationships with each other. And I think we tackle the first half of the document first, just so that we got common terminology. So I'm going to intentionally leave that last section relatively bare right now. This one over here, it's storage orchestration and management. And we can fill in the subsections later. It feels like we might want to similarly break it down into, orchestration of block stores, orchestration of databases, orchestration of file systems, etc. But I may be off there. We'll figure that out as we go. The other area that I think we might be missing is how these things plug together and build on top of each other. And I'm not sure, again, I sort of intentionally ordered the document in such a way that the more primitive systems are first. So a block store is, typically fairly low down in a stack of storage. And then, we could just incrementally describe how these things fit together as you go through the document, perhaps with I'm a little hesitant about, just drawing reference architecture diagrams, because from my experience, and feel free to agree with me, but there are so many different variants of how these things fit together that one cannot actually say that file systems are always built on top of block stores, because they're not. And databases are not always built on top of file systems or block stores. There's many different ways of skinning cats. And specifically when you get to the distributed stores, the landscape gets even more confusing. So I would kind of lean towards describing these things under each of the headings I've mentioned. So when we get to distributed file systems, for example, we can say that local file systems are typically built on top of local block stores. I think that's a reasonable statement. Maybe there's some exceptions, we can call them out. Remote file systems are similarly often built on remote block stores. Distributed file systems, on the other hand, there are different ways of exposing these things. You get file systems on top of S3, for example, that I've seen before. And those are clearly very different than other kinds of distributed file systems.
I think it's more important to describe, because, as you said, there are so many infinite permutations, right? I mean, you could have local file systems built in distributed block stores, for example, or whatever, or on top of object stores or things like that. But I think it's more important to describe the type of functionality that the user is meant to expect out of the different types of technologies. So for example, a local file system is available on one node only, and is typically not shared and those sort of things. Whereas there are shared file systems that can be used by more than one applications or more than one node at the same time, and those are probably more important as differentiators to how people consume the technology as opposed to how the technology is built, if you see what I mean.
Yeah, I guess the only problem with that is that sometimes how the technology is built fundamentally affects what the user experiences. So, if a user is consuming a remote block store that is on a high performance enterprise storage system, they have a different experience in store built on S3. The performance is, very, very different. The durability is noticeably different. S3, I just had a look just now, is designed for 10 nines availability. I don't think that can be said of, even the fanciest enterprise storage system. So there are fundamental differences. You might, in both cases, you might be consuming a remote block store, for example, or a remote file system, but the user experience is extremely different along the axes that I mentioned here. So yeah, we just need to be
very true. Yeah, that's a good point.
Right. So the next order of business. Oh, are we out of time? We are. Okay, so we need some primary authors for this document. Do we have any hands in the air?
Yeah, I'm happy to work on this.
Okay. Anyone else? Gone. If you would like to join Alex, please reach out to him, but we will nominate Alex as at least one of the primary authors of this document. I will happily help where I can, but I would like not to be the primary author personally. One, because I'm not a storage expert, and two, I think I would like the document to come from this group as a whole, not from me and the TOC. So let's go ahead on that basis. And we're out of time, so we better wrap up and carry on. Do we have these meetings once a week or every 2 weeks? I don't recall.
It's every 2 weeks.
Okay, so we'll see everyone in 2 weeks. Alex, you and I can perhaps make some progress on the doc before the next meeting.
Yep, brilliant. Sounds good.
Cool. Cheers, guys.
All right. Thank you. Bye.
Bye.